see here is that we have some characteristics of a particular quadratic function or of quadratic functions. And so when we look at part A, if we want to determine whether or not the graph opens up or down, we want to look at the format of a quadratic function. So a quadratic function comes in the format of the function is defined where we have a leading coefficient we call A that will be in front of the x squared. We have the b, which will be in front of the x, and we have the constant c. Now, the b and the c have values or importance in other scenarios, which we'll use in part B. But in this particular case, the value we want to look at, the value that determines whether or not a quadratic function opens up or opens down, is the a value. And so if we find that the a value is positive or greater than 0, then we know that our quadratic is going to open up. And so we know that it's going to look, something not exactly like this, but it's going to open up, right? We don't know where the intersects are and stuff like that. We just know it's going to open up. If the a value is less than 0, that means it's negative. It's going to open down. All right. Now, so that's part A. We look at our guy right here. So for part A, we know that since our a value is equal to 3, then our function, that's positive, so our function is going to open up, and therefore it's going to have a minimum. All right, and so that would be called a minimum right here in our notes, and this would be called a maximum right here because that's our highest point of the graph, and this is going to be our lowest point of the graph. All right, part B. So part B, to actually identify that minimum value, so for part B, we have something where we can identify where the vertex of the graph is. And so the vertex of the graph can be located by finding the x-coordinate. And so the x-coordinate of that vertex is found by taking negative b over 2a. And so like I told you before, or I have mentioned before, that the b term is going to come into play in these situations. And so at this spot, what we can do is we can take the value. So we know from this particular case right here that our a is equal to 3, our b is equal to negative 18, and our c is equal to negative 9. Now, the reason that we know that the b and the c values are negatives is because our actual formula or function format that we go by has all addition. And so when we look at this, we're going to see this as being 3x squared plus a negative 18x. So we can see we have a negative plus a negative 9. So we can see we have a negative for both B and for C. So to find our vertex, we'll say that the x is equal to a negative, and our B is negative 18. So it's going to be a negative 18. So the negative from the formula and the negative value over 2 times our negative 9, excuse me, I put the wrong number in there. Let's not say negative 9. Let's go with 3. My bad. Because it's our a value, not our c value. Okay, so our a is 3. When we simplify that, 2 negatives make a positive, so it becomes 18 over 6, which is equal to 3. Sorry about that. That's supposed to be equals 3. Equals 3. Now that's the x portion. So to find the y portion, because remember, like a vertex or that low point is going to be an ordered pair. So we're going to have an x comma y value. So right now our x value is 3. So to find our y value, we'll take that and we'll plug it back into the actual function. So our original function, so think about this as like saying we want to evaluate f of x at 3. That would be equal to 3 times 3 squared, sorry about that, minus 18 times 3. And I just use parentheses just because they help me group what I'm doing. I pull out my calculator. I think probably depending on the calculator that you have, it's probably the most valuable is that if we just go through and simplify this at one time, or as singular parts, excuse me. So 3 squared is 9, right? So 9 times 3, so this would be equal to 27. And then we have here, we got 18 times 3, that's 54. We got the minus sign we bring down, and we got the minus 9. And then we just start simplifying that. So we got 27 minus 54 minus 9 pull out my calculator again, 27 minus 54 minus 9, and I find out that I get negative 36. So my function evaluated at 3 is equal to negative 36. I bring that up here to my ordered pair, and I find out that my function's vertex occurs at 3 comma negative 36. That's part B. That's our solution for part B. All right, part C, identify the domain and range. Now, I know this particular problem says that, and I apologize, I'm looking here at the actual format. So the minimum and maximum value in this case would be negative 36. That's the y, and that occurs at x equals 3. So that's just your x and your y value right there that you have. So now, I know we said not to graph this, but I think it's valuable for us to kind of look at the graph to be able to understand. So I'm going to hit pause and open up another tool real quickly. I'll be right back. Okay, so I'm back. And so what I did was I went and pulled out a tool called Desmos. And so this is Desmos calculator, Desmos graphing calculator. You'll notice that this equation is exactly the equation we were looking at. And what happens here is that I can kind of get a visual of what this graph really looks like. Now, let's kind of break this down. So we're on part C, and we need to remember like what domain and range means. So X is going to correlate with your domain, and the Y is going to correlate with your range. So when we talk about the domain is like saying like, what X's can we plug into this function to get a Y value out? Well, the honest answer is that I can plug in any X, right? So if I took this and I kept on zooming it out, I know you're like, well, wait, what do you mean? At negative 20, I can't see the graph, but that graph's going on forever. It's just going up really, really fast. So any X can be plugged in. If you plug in negative 60 in this equation, you're going to get a number out, and it's going to be really big. If you plug in positive 140, you're going to get a number out, but it's going to be really big. So in this case, my domain would be what we say, all real numbers. And we'll look at how to put that in, all real numbers. That can also be listed as negative infinity to positive infinity. That means like any number between there. You could also use the symbol for a capital R, which stands for all real numbers. Our range, on the other hand, is something that's not every number does not get put in. So remember, domain is the input. Domain is what we put in, and range is what we get out, right? So we insert a certain amount of things into something, we get something out, and that's our range. So in this particular case, when we look at our graph, we have to understand here is that this is the lowest spot. So remember, range is y value, so y goes up and down. So our graph does not go below that location right there. That's the lowest spot. So that vertex we found that was at 3 comma negative 36. Oops. That is basically like identifying for us what our range is going to be. Because at that point, we know that this location right here, our graph doesn't go any lower than that line right there. And that line right there is negative 36. So our range is going to be tied to that. So our graph can include negative 36. So we're going to put a bracket, because that bracket signifies including 36. So it starts at negative 36 and it goes to positive infinity. It starts here and it goes up for ever and ever and ever and ever. All right, so domain and range, that, like just practicing that terminology. I know the problem said don't use a graph, but I think looking at a graph will help solidify the problem or the concept. So now let's go ahead and go back to our problem, and let's take a look at how we would put that in. I'm gonna hit pause and be right back. So what I'm doing is that for this particular problem, I'm going and finishing it up, and I cleared my screen, so I'm putting in my minimum value would occur at negative 36 when x is equal to 3, and that's what we saw in our graph. I check that, I get that good. And now it's asking me to type in the domain, and it's saying an interval notation. So interval notation is going to be where we're using parentheses. And so we would say from negative infinity, comma, positive infinity. And so that would be an interval notation. So remember, that's saying all real numbers. So any x can be plugged in. All right, and then last, our range. Once again, they want to know the interval notation. So remember I told you about using the bracket And so in that particular case, your bracket's going to be on your keyboard. And we're going to start at negative 36. And we're going to go to positive infinity. So we use that infinity down here. And we close it off of the bracket. Now, just as a quick reminder, when we use a bracket signifies including that spot. So for example, what we're saying is that we're starting at negative 36 and we're going forever this way. And if we used a parentheses, that would mean starting at or not including. So starting, that'd be like, you're say like 36 is your starting location. So negative 36 and going this way. Or we're really going up in this particular case, but just kind of giving that idea. So